Hey everyone, and welcome. Today we are diving into a concept in Java that honestly feels a little bit like magic. We're talking about how to save your objects from just vanishing the second your program stops. We're talking about serialization. So to really get why this is so important, let's kick things off with a problem that I guarantee every single developer has smashed into at some point.
You know the feeling, right? You've spent all this time creating objects, setting them up just right, building this whole universe of data inside your app, and then the program closes. What happens to all of that hard work?
That's right, they're gone. Just poof. They live in RAM, you see, which is what we call volatile memory. As soon as the power gets cut or the program ends, it all gets wiped completely clean. It's like building an incredible sandcastle right by the ocean. The tide comes in, and, well, it's gone. But what if, right before that tide came rushing in, you could take a perfect, three-dimensional snapshot of your sandcastle? One that you could store away and use to rebuild it later exactly as it was, down to the last grain of sand. Well, that's pretty much the trick Java has up its sleeve.
And this is the core idea right here. We call it serialization. Think of it like flash freezing. You take your live, complex, running object and you convert it into a simple, durable format, a stream of bytes that can be easily saved to a file or even sent across the internet.
And as you can see, it's a complete round trip. You start with your live object, you serialize it, that's the freezing part. You can then store that frozen state or send it wherever it needs to go. And then, when you need it again, you deserialize it. That's the thawing process. And just like that, you have a perfect, living copy of your original object right back in memory, ready to go.
Okay, theory is great, but seeing it in code is what makes it all click. And what's really interesting isn't just how to do it, but how to do it smartly. All right, let's get into the code. First, you have to stamp your class by saying implements serializable. Now, this is what's called a marker interface. That means there are no methods to implement. You're just giving Java a permission slip to freeze-dry objects of this type. Now, look closely at that serial view ID. This is super important. It's a version number for your class. If you change the class later, this ID helps Java figure out if an old saved object can still work with the new code. Forgetting this can cause massive headaches later. And see that transient keyword next to the password? That's our secret weapon for controlling exactly what gets saved. Now for the main event. We create our user object. Then we set up an object output stream, which basically acts as a translator, turning our live object into that stream of bytes. Finally, we call one simple method, writeObject, and this is where it gets really clever. Remember that transient keyword? Because we mark the password field as transient, the serialization process just skips it. It completely ignores it. So the user.ser file gets the username, but the sensitive password never ever gets written to the disk. It's a simple but really powerful way to control your data and boost security.
And just like that, your object's state is captured. It's not just a temporary guess in your computer's memory anymore. It's a persistent, version-controlled piece of data with sensitive info intentionally left out, all tucked away safely in a file.
Okay, so we can save a user object and do it intelligently. That's a really powerful building block. But where does this become a true game changer in the real world?
The applications for this are absolutely everywhere. Ever played a game and saved your progress? That's probably serialization, freezing your game state into a file. Ever use an app that loads crazy fast because it has cached a bunch of complex data? That could be serialization. It's also the backbone for communication in big distributed systems, allowing one Java program to literally send a live object to another program running on a totally different machine.
So, let's pull all this together. We've seen the problem of our objects just vanishing, and we've uncovered Java's elegant and surprisingly smart solution.
This right here is the key takeaway. You are transforming your data. You're taking something that is by its very nature temporary and fragile, and you're turning it into something permanent and portable. It's a fundamental shift in how you can think about and use your data.
And that's really the question I want to leave you with. Once you have the power to make your objects outlive the very program that created them, a whole new world of possibilities just opens up. So, what are you going to build with it?